Please be patient.
Okay, du schaltest noch um, oder? Hi folks, welcome to our today's webinar. We highly appreciate your interest and your participation in our webinar today. My name is Amar Löffler, Head of Technical Support and Training, assisted like usual with my colleagues or from my colleague Christoph Kienzle here again at the technical control panel in the background, and he will support as well. So the chat box which you may use in the event of some questions are arising, and at the end of our approximately 35-40 minutes webinar, you have the option to post some questions to us. Feel free. Hopefully you will have some interesting minutes with us. We highly appreciate this. What is our content of today? You discovered with the intro with this nice movie. We talk about these iON sensors and temperature controllers like we do have here. And I like to make you acquainted with some details, the abilities of these really powerful eye candies, which we do have in our Theben product range since a couple of months. What's the content of the day in general? So short and brief, the applications, finally, some details to the product. We will have an insight in the application settings and the abilities of the controllers. Then we will probably have a short insight in, let's say, the programming. And finally, we do have here a live demo because, you know, we have mentioned app remote control, you see on top. So that means we have a unique option, especially with the iON 108. So we have a visualization on board, and you can operate or monitor finally on your mobile these, let's say, room dependent functions. And you do not need any visualization. The visualization is on board on your mobile, supported by iON 108. And I want to make you acquainted with how you have to do this and how easy it is finally to link from the mobile to the iON 108. Hopefully you have some interesting moments. The important thing is finally that this, especially this powerful controller, the iON 108, supports you with 20 individual functions. What does it mean? Switching, dimming, blinds, displaying values, RTR, sending values, LED light control in different abilities, RGB, RGB white, and XY coordinate control LEDs, for instance, and further on. So we have a really powerful package in the application in total. If we count together, 20 individual functions plus supplementarily room temperature control, heating and cooling, and we do support as well, like you can discover here, we support as well alarm function. So that means you will have as well a display which is giving you a certain response in the event when probably an alarm is started due to fire sensor or a CO2 sensor or a CO sensor, so color monoxide. And for instance, or window is broken, however. So all these functions you get in this iON 108. The application, when we focus first of all on the room temperature control, so the temperature control in its own, you see here we do have here the option just heating control, or if in most of the cases we need this application, heating and cooling. So it depends on which zone of the world you are located, you definitely need the cooling. This controller, this NAS controller is supporting that. Plus, you discover probably here fan stages, so we can do the airing, fan coil control, for instance, or air recoveries. However, the controller supports all these functions. Yeah, it's up to you, your choice. And we do have as well, so it pops up here, we do have the option either to use this temperature sensor, which is inbuilt here, especially here on top, in the top flap in the top cover. There is behind the temperature sensor, and the temperature sensor is giving you feedback from the current, let's say, room temperature. Or optionally, you can select here external sensor. So probably there is a need in an industrial area or in a huge conference center, however, to tap somewhere else the real room temperature at a specific place. So we can deactivate the internal sensor and activate the external sensor. And due to that, we can really measure in the spot where you have specified, and this nice room temperature controller is controlling accordingly. We have all these flexibilities. Yeah, what's supporting? The sensor itself supports 4-button operation. So that means I take here a real one. So we do have here left, right, up, down. In the display, we see later on in live, so how it works. So that means in the middle, in the center of this room temperature controller, you always have the current main function, like we do have here. We do have here these main lights, yeah, and the main lights you can on off with the flap here on top, or here you off it with pressing on this flap here, or if you press here on this key on the right hand side, so then you will swap the page from ceiling light to the next function is here the blinds, yeah, and vice versa on this side here behind, okay, hidden behind my presentation here. So we'll have as well a key, you press it, and then you will get another light function which we do have here, and this light function you can control individually. So it's a simple operation to operate, and finally as well to monitor values. So it's just a function on, off, or up and down, but you can display here as well, depends on how the programming finally is, you can display here as well, so carbon dioxide values, temperature values, or fan speeds or whatever, yeah. So we have all the options included in this nice iON 108. And we have the option as well on long press function. So that means if you press longer time on this button here, so then we change the display, and you do have just the RTR settings, so your base set point, for instance, or the current room temperature, or the operating mode is displayed finally. And then with the up and with the down button, you can select the reasonable, let's say, function, or to increase or decrease finally the desired room temperature. Yeah, that easy. Yeah. So the labeling itself you can do in a different way. Either there is space to type in your specific naming of the function, and as well you have the option in a database. We have here a drop-down box, and in this drop-down box you find several let's say icons which you can use, and these icons finally are popping up here in the center of the display, giving you an indication, so what is about what function we do have here currently. Probably it might be probably of interest when such kind of nice sensors are installed in hotel rooms, yeah, or probably in your private area during the nighttime. These displays are really shining rather bright. Probably you may be disturbed in your sleep, however, and due to that we have the options as well to select switch off the display during the nighttime or reduce during the nighttime, for instance, or you can do it as well in an office or in a public building via bus. You can control the display as well through the bus communication, so you can adjust it however you like it. In regard of the applications or the huge variety of applications, you discover here some. So we talk about switching, dimming, blinds, priority, value, percentage value, floating point numbers, and so on, down to XY color value, plus, you can scroll down further, plus visualization of values, carbon dioxide percentage, and whatnot. Yeah. So you see there is a powerful application in the background of this controller. Supporting as well, specifically RGB lights. Yeah, RGB lights or RGBW, yeah, depends. Or you can control as well LED lights according to these XY color coordinates, for instance, however you like it. Yeah, with these abilities, you can do as well control color temperature. Yeah, cold white, warm white, however, always related to the ballast, to the control gear, which is applicated and which is linked to the LED lights on their own. Yeah, you see, we are well prepared. And this you can call up easily with the iON 108. Yeah, when it comes to, let's say, displaying finally values, so for instance, we can use our iON, so the CO2 sensor, which is ideal, let's say, application to measure permanently how is the CO2 quality in the room. We measure finally the percentage value of the humidity or the air pressure if you're eager to know what's the about, and we can give as well a response of the temperature, and you can link it directly to the iON 108 application. So for instance, if you have chosen display value is data point 9, so ideal, for instance, to display here CO2 values, yeah, for schools, public buildings, municipalities, and so on. So then you have a clear picture, what's the about, what is the value ppm currently in the room. Yeah, the heading in this case could be when we control or when we display CO2, then you type in here ppm, so parts per million is the indication for CO2 measuring, and then finally you get as a result in the display displayed here. So what is displayed as a number? So that's exactly CO2, for instance. Why air pressure? There is a short secret behind. There is a relation between measuring of CO2 is always related to the altitude over sea level of the installation. So that means when we, for instance, take in account, we do have here down Singapore or so, so we are almost 10 meters above sea level, even less. And we take there a CO2 sensor, just as an example. So the quality or the result of the measured CO2 value is finally different to our place here in Europe, in Germany, in the southern part of Germany. We are located about 500 meters above sea level, roughly. So that means the measured ppm value in CO2 may differ to Singapore. Yeah. So this is related to the air pressure, to the level above sea level. Yeah. And due to that, the air pressure is different in Singapore in comparison to Germany, to Haigerloch, our city here where Teben is located. So due to that, we do the calibration internally when we know the air pressure, so we calibrate as well, so the CO2, so in order to get these measured value really precise. But back coming to the iON 108, we get it displayed, the really good, let's say, measured value, we get it displayed here, for instance, as a data point 9 value on our iON 108. And finally, don't forget, so with this nice iON 108, So we can do room temperature control, like mentioned. Yeah, so heating control or heating and cooling control. And we support with the iON 108 either if we control, for instance, these HM6T, so this heating actuator, for instance, we can support as a room temperature controller. So we get the heating value, or we send the heating value from the iON 108 to the actuator, or we just, it's a matter of how you want to process and how you do the setup. Or you can send as well just the room temperature, which is measured here somewhere in the upper flap, and you send the temperature value to the actuator, and the actuator is doing the control values on his own. So he's doing the control application on his own, because our heating actuator can be either a heating actuator or a heating controller. And if he acts as a heating controller, so he needs just the temperature. If you want to do so just take the temperature here, send it to the actuator, and the actuator is doing the controlling on his own. So that means you can manipulate, you can modify the set temperatures here on the room temperature. Yeah, it's just preset in the actuator. And for this purpose, you need, as an example, you need a visualization or external access to do so. Or you send from here the control value, the room temperature controller, the iON 108 is the control spot where you measure, where you control, and where you send the heating value. And anytime you have the option to lower the temperature or to rise the temperature, which is probably be a preset in the room. The interesting point is finally that the iON 108 is, well, let's say, a kind of visualization on its own. So that means we can link the Theban iON app, which you get on the App Store, on the Play Store, for instance, for free, by the way. You link it, and then all the functions which are programmed herein, you can display on your app, and you can operate with this app remotely. You do not need any visualization. The visualization is with you. It's an absolutely unique solution, which Theban do have since approximately half a year. And this is absolutely benchmark currently. Yeah. So nice tool, nice thing. Yeah. Could be an option as well. So not to control a heating actuator in a DB board. Here you discover an example. So we do have flush mounted actuators, heating actuators, and we just take the temperature from a temperature probe, which you see here on the left hand side, and we link, or we take the temperature probe here, and then we link it with the app, and we do have here visualization and can do the things, the control accordingly. Yeah, so easy it could be. So finally, we support with the RTR, room temperature control, heating and cooling, which is displayed here, the fan coil actuator. We can display any kind of values on the actuator, and on the left hand side you discover the Teprema 360, and this, for instance, gives you for office buildings, which we do have here in my background, and if the room, the office or the meeting room is occupied, so then, for instance, the RTR switches from standby into comfort mode in probably the air conditioning. Yeah, so that means we do have a standby when the meeting starts, so then the air condition starts in comfort mode and gives us the most comfortable temperature accordingly. So it's rather simple, rather easy, and so just this picture here supporting heating and cooling, so ventilating and air conditioning. So a few basics probably make sense. So how is finally a room temperature controller acting, or the main principle finally? So we do have here some impacts from the outside, affecting finally the inside of a building. This is the weather condition, for instance, always related to the insulation, finally, from a building itself. Then we do have here internally sources, like, for instance, electronic stuff. We do have here the warmth of heating. We do have here as well people walking, working inside, for instance, which are giving a certain warmth into the room. And all this is measured by a room temperature controller, calculated how it is the situation inside, how is the temperature inside, and what is the preset, the base set temperature, which we want to have. And the room temperature controller is calculating finally the valve position or the heating activating valve value accordingly, giving to a valve, for instance, or a motor-driven valve, however, to open or to close a valve to give the reasonable warmth into the room. And this cycle, you see here, this cycle is permanently running, yeah, internally. If there are some modifications, there is a window open, the temperature drops down. So, and permanently the room temperature controller is measuring how the situation currently, for instance, is. And this is finally done by a perfect room temperature controller, and this in to give them a certain, let's say, phase or a certain appearance. Room temperature controller is like that. Then probably we do have here a motor-driven valve, which is linked to a heating. In this case, to a heating, could be as well a split unit, could be as well a HVAC solution, for instance, in hotels and in more prestigious big buildings, for instance. And all these are permanently acting and linked together in a circle in order to give you the reasonable room temperature which you have preset finally. And for that purpose, you need a powerful controller, which is absolutely flexible in his control application. We do support here PWM control, and as well, if you like, the hysteresis control. Frank speaking, so when we talk about, let's say, split units, when we talk about heating and cooling systems, so always, let's say, recommended to use PWM control when it comes to a floor heating or floor cooling or ceiling cooling, however. So then the hysteresis control is good enough, because this is related to a certain speed of the heating or of the cooling source. And when it comes to a ceiling or when it comes to a floor heating or cooling, so then this procedure is rather slow, and due to that, hysteresis control is more than sufficient. When we intend to control here such kind of radiators or systems like that, who are rather fast in their absorbing of warmth or absorbing of cold liquid or cold temperature into the room, so then most appreciated and most to be recommended is finally the PWM control. Yeah, and finally, when it comes to, let's say, the different systems or the recommendations, so what we have to consider, what are the advantages here, what are the advantages there. So you see, for instance, here we do have here underfloor heating, warm water. So what is the advantage? We have here absolutely uniformly let's say transmission of the warmth, because we have a good, let's say, network in the ground. So we have a perfect let's say distribution of the warmth in the ground. Disadvantages: such kind of systems are slow. Due to that, we have to adjust, let's say, the PWM settings. So for instance, 15-20 minutes, even more, 20 minutes plus, depends on how the squid finally is, where these heating sources are installed. When it comes to radiators, so which are mostly positioned next to a window, which are rather fast, so you have a relatively fast emission of the room temperature. Yeah, this is a big advantage of that. But we have more a spotted absorbing of warmth. It's not like in underfloor heating where it is rather uniformly. So it's more a spot. Yeah, if you take, for instance, a measuring gauge of temperature and you position to the radiator, so you easily have depends on the temperature differences. You easily can have 40 degrees on the radiators, but 2 meters left and right hand side, so the temperature is probably 25 degrees or so. So we talk about more a spot, let's say, emission of the warmth. The disadvantage in this case is that the air is rather dry, especially during the heating season. Yeah, that's related to this heating procedure. When we do have underfloor heating, for instance, it's not that tremendous. But when it comes to radiators, you have mostly dry air, so you have to humidify mostly in the heating season. This we have to do. When it comes to, let's say, heating fanners, so heating fanners, where you find it? Finally, heating fanners you get in, let's say, stocking areas, big warehouses, and so on. So they are rather fast. Yeah, huge, let's say, systems blowing warm air into the room. This is basically an advantage. We do have disadvantage. I do not have rather of them. Heating fanners, electrical heating, so same can say, but the energy consumption of electrical heaters and fanners is rather high, because you need rather huge energy as a source to heat up the air streaming through these heating resistor, finally blown through the fans into the room. But it's rather fast, frank speaking. Convector heating, so that means electrical convector heating. Advantage like this one here, and this one here. So all of these three, they are noiseless, silent, because there is no noise due to fans also. But the energy consumption as well here is rather high. So just to separate a little bit what kind of, let's say, heating systems we do have, and what is the advantage or disadvantage here and there. Just 2 points which I like to mention, because this we regularly get as requests into the telephone hotline. So my colleagues in the telephone hotline have to support such kind of things. So what if, for instance, we do have 3-4 radiators in a room, and the different radiators, when I send with the bus monitor or with the room temperature controller on all of these 4 radiators, the heating valve value 100%, so the valves are totally open, but the temperature on these 4 radiators are different. So then it's definitively the fault that we don't have a perfect hydraulic adjustment. And this is not your turn. Yeah, this is the turn of the heating specialist. Finally, he has to do the hydraulic adjustment here. There is a small, let's say a small gear, which has to be, let's say, set in the right position, that the water flow is equal on all these radiators in the room. You can't do any modifications from the application side, from the ETS settings. This is a thing which is coming from the hardware, and this is again not your turn. And probably you will discover some, let's say, some noises in these heating systems, so are kind of bubbling, and this is a typical indication that there is air in the heating system, and due to that, air heats up different to warm water or to water in general. And due to that, we have, first of all, bubbles, so a noise. And secondary, we don't have, let's say, a permanently and a homogeneously, let's say, warmth in a radiator. We have just a certain spot on the radiator when you tap with your hand. And sorry to say, you can't adjust anything in the ETS, in the application setting. This is just hardware. And then we finalize immediately again. So what is ongoing in a temperature controller itself? So we do have here, let's say, a kind of scheme. The heating control is like that. So for instance, this is our current temperature control, 19 degrees. Yeah. So, and this is our desired temperature, 21 degrees. So we have a gap of 2 degrees. And there's a kind of triangle. It's a digital triangle upon this control, let's say, scheme. And the effect is finally, so we have currently 19 degrees. And here is finally the touch point of this triangle to the current temperature. So that means the heating starts. And here, the heating ends. And as closer we come finally to our desired temperature, yeah, as smaller this cycle on off of the heating finally becomes. And this is an automatism. You have not to take care about that. But if you open the monitor, the bus monitor, and you have a brief look on the bus monitor, how is the current, let's say, heating control value, so which is given in percent. So you might probably understand now, so what if, so as far you are from your desired temperature, as bigger finally the percentage value of the heating command finally is, as closer you come to your desired temperature, as shorter this heating control command finally becomes. Pretty simple in the application. Yeah, when we want to understand, so what has to be linked, what has to be done. So we talk about RTR control. I focus here a little bit on the heating application. So what has to be done? I think it's rather simple to indicate here. You need, for instance, from a heating actuator, you need a continuous activating value, which has to be linked finally to the iON 108, so the control activated value send. So it's exactly that here. This has to be linked finally to here. Then in the event of that, for instance, you have integrated a presence sensor for this nice office, which we do have here directly in my background. So if somebody is there, we do have a meeting, I'm in the office working, for instance, so we need a presence. Presence has to be linked here. When the day is done, so that means we have finished our work, can happily leave the office and enjoy the time with our family at the night time. So then we leave the room, the presence sensor discovers, sends the trigger, finally switches off, and in the entire building, for instance, with the time frame, we can set for instance, now night break. So the heating, for instance, stops, reduces the temperature in the entire building. Just a few less communication objects which are required to bring this, let's say, comfortable control for office building, for schoolrooms or whatever in control. As well, don't forget, we talk about energy savings at all. So nevertheless, if you talk about heating control or if you talk about cooling control, if there is an option, if we do have the event to open a window, to open a door to a balcony or to a terrace in our office, however, so then we can stop the heating or we can stop the cooling accordingly. So you discover here, we do have here in the room temperature control settings, we do have here the reasonable application settings. And there is something which is unique, and I think this is of high interest. And for that purpose, I switch now to my mobile. So we do have here the iON app. So I open the iON app now, and for this purpose, I need my, sorry, it's that one here, exactly. So we do have here the iON 108. We do have here a heating actuator, and I just right now, link my app to the iON 108. I start the search. So, okay, for this purpose, the Bluetooth communication has to be opened in your mobile. There is one of these iONs found. Yes, I want to have it. I confirm it by pressing OK. And if you like, you can rename this. For instance, here, I name it my office. In the event of, for instance, you do have more of these controllers in a big room or in neighbored offices, however, I open this. So now you get the query, enter PIN code. And immediately you discover probably now on my iON here, on my iON, we do have displayed here a pin code. This pin code I have to insert. And now I'm linked directly from my mobile to the iON and all the functions which are programmed here in the iON themselves. So if I open, so we do have here the heating application. And the heating application, so I press now here for a few seconds, and then you see the iON turns to heating control. With a step here, I go through, so that means we do have here currently a standby mode, which is equal to our displayed app on the right hand side. We do have here standby. I turn here to comfort mode, and immediately you see the app controls here actively the iON 108, and the temperature controller turns to comfort mode. I want to know how the current situation is. So the heating control command is 28%, which finally gives you the feedback here. Okay, channel 1 is currently in the heating mode, but we are rather close to our temperature. Our temperature you discover here. Finally, you see actual value on the app on the right hand side. The actual value is 20.3 degrees. Our desired set point is 21 degrees. So there is just a rather small gap of 0.6 degrees, which is finally to be controlled. And due to that, we have a rather small value of the control command finally, which is 28 degrees. Probably if I put my hands for a couple of seconds upon, so probably this value will definitively reduce. It must definitively, because the heating actuator even have switched off. So there's a short delay time nevertheless. And you see now 24 degrees. So we come closer to our desired temperature, and that's it. So with a short step on the right hand side, so we come back to our main functions. Main functions, we do have here the option right and left hand side, and with the up and down we can control. If I go back to my operation, so you discover here, so I do have here, for instance, switching control commands. I do have here the dimming control commands. I can switch here or position here any kind of slats or blinds. However, I do have here, for instance, the RGB light control. And in this case, I do have here, for instance, any kind of light. I haven't given a reasonable name, but you discover, okay, there is nothing to do, nothing to add. You do not need any visualization. The visualization is here on board. All the functions positioned here are immediately converted into the visualization of the iON. If you want to add, for instance, any kind of scenes or so, you can add here as well a TV scene, give them an icon, and that's it. And then you can, for instance, give here the reasonable percentage values, and the scene is finally predefined. And so you can add or rename these scenes as well. So you have a lot of flexibilities finally in regards of the iON 108. It's eye candy and on its own, and it's an absolutely powerful application on its own, powerful product on its own, assisted or surrounded by the iON 104 or the iON 102. No display, but even from the application settings, really powerful. Hopefully you could capture some good ideas, and looking forward to see you next time. Our next webinar is heading us in beginning of June. We talk about sequence control quite plainly. So I'll give you some insights, what you can do with sequences, how powerful our sequence application finally is, and finally, how easy it is. Okay. Hopefully see you soon in one of our webinars. Have a good time. See you.